welcome to the channel. In this playlist you'll find all things related to differentiation, and in this video in particular we're going to be looking at a worked example. So let's have a look. Here we have a question which is actually an old examination question. So let's have a look at what they say. Here they say prove that this equation here, or from that equation you can find this particular derivative, right? Now the biggest challenge with examinations and questions like this is that they don't tell you how you're supposed to solve this question, and you're supposed to look at the question itself and figure out step by step which rules you need to use and which bodies of work you need to draw on, because it's different from when you're in class. In class, at this point we're looking at implicit differentiation, for example, so those are the rules that you need to apply. Whereas when you're working in an examination setting, you don't know what you're supposed to use, because there is really no they don't explicitly tell you use this rule, right? So you have to look at the question in order to find some clues. Okay, so we are going to be looking at this question here, right? So one thing you need to notice about the question is they say that you need to prove that this function, from this function you get this derivative. Now when they write the derivative like that, it actually gives you a clue as to what is the dependent and what is the independent variable. And I mean, you working in x's and y's, right? So you assume that y is the dependent and x is the independent, because that's what you're used to. But when you move on to the higher level of mathematics, it's very important for you to know what that is going to be, because you're not always going to be working in x and y. So this means here that you're going to be differentiating this function with respect to x, okay? Which is important, because what you'll notice in the question is, see where these y's are, right? These y's are embedded within functions themselves. So when I say embedded within functions, I mean it's embedded within a square root over here. It's part of a product here, and it's embedded underneath the square root as well, which implies you're going to have to use implicit differentiation, because y itself is dependent on x. Okay, another thing you'll notice is that you've got square roots all over the place, and usually when you've got square roots like this all over the place, it implies that you're going to have to use exponential rules at some point. Okay, usually with exams or tests, the way lecturers like to set it is that they like to put many sections in one question, right? That way they cut down on the number of questions they have to ask you, because you only have so much amount of time to complete the question paper. Okay, so let's have a look at this. Okay, so I'm going to start with the left hand side, and the left hand side is equal to sine of the square root x times y. Okay, and because that's a square root over there, what I'm going to do is I'm going to change it using my exponential rules, and I'm going to write it like this, to the power a half, right? And then I'm going to take the derivative of the left hand side, right? Okay, so if you look at the function that we've got here, there are many parts to this function. You have a sine function over here, and then you have the half power, which is the square root, and inside of that you've got two other functions multiplied by one another as well. So this, you would have to apply your chain rule, because what you've got is effectively layers of functions happening here. Or sometimes lecturers will speak about layers of an onion, how to get to the core of an apple. They use lots of different examples, right? But you just need to know, how do you get to your independent variable? And in this case, your independent variable is x, right? So here you need to move all the way from the outside. The first function you're going to hit, let's use green. The first function you're going to hit here is your sine function, right? If you're working from the outside in, it's going to be the sine part. The derivative of any sine function is going to be cosine. right? So we write cos, and it's going to be cos of the argument, which is xy to the half, right? So that's the first part of it. So once you get past the sine function, then you get down to the next part, which is this bracket over here, right? And this bracket is the half power. Yeah? So if you look at the half power, that's just your power rule, which means you have a half, whatever's in the bracket stays, and it is the power minus 1, so it's going to be minus half, right? So that's the next layer. Your final layer that you're going to deal with, let's get this one, is going to be whatever is inside of that bracket, right? So this here is the final layer, because you finally reached your independent variable over there, right? So then if you look at what's inside of that bracket, you have a product, right? And when you're differentiating a product, it means you need to use your product rule. So your product rule says it is the derivative of the first part of your function, which is 1, times the second, plus the first part of the function, times the derivative of the second. Now the derivative of y, remember, y itself is dependent on x. So that is implicit differentiation. So the derivative of y is going to be 1 times your derivative here, right? Because it's implicit. Okay, so now let me just neaten this up a little bit. So I'm going to change these half powers back to square roots. So I'm going to have cos square root of xy over 2 square root of xy times y plus x dy dx. Okay, so that is the derivative of your left-hand side. So now let's look at the derivative of our right-hand side. So our right-hand side is equal to, let's see, we've got square root of y minus square root of x. Okay, so if we now take the derivative with respect to x of that right-hand side, right? And before I do that, I'm going to change these square roots into powers using exponents rules. So that's y to the power half minus x to the power half. Okay? So here we have a base of y and a power of a half, which means we're looking at power rule. So that's going to be a half y, the half minus 1, which means it is minus a half. Y itself is a function of x, so you have to put in dy dx. Because remember, whenever you are differentiating, the last part of the derivative has to be with respect to the independent variable. So in this case, for x, right? So here you've got minus a half, and that's going to be x to the minus a half. Because your derivative is with respect to x, and here you're sitting with the x, it stays like that. So then we've got a half. I'm just changing this, dy dx minus a half 2x. Okay, so now we've got the left-hand side and we have the derivative of our right-hand side, and we're going to equate those two. Okay, so now what I've done is I've equated the derivative of the left-hand side equal to the derivative of our right-hand side, okay? But what is our goal? Our goal is to find the derivative dy dx on its own, okay? So here you'll see that the dy dx is inside of the bracket over there, and here you have it on the left-hand side and there it's on the right-hand side. So you want to gather all the derivatives together. Right, so what I'm going to do is I'm first going to multiply this bracket out. So I'm going to have y cos square root of xy over 2 square root of xy, x cos square root of xy over 2 square root of xy dy dx. Now you don't have to write down every step, right? If you can remember what you're doing, then you're more than welcome to leave steps out, right? So I want to keep this derivative, right? So I want to keep that piece on the left-hand side, and I want to move that piece also to the left-hand side. The rest of the expressions I want to take to the right-hand side. So we've got let me just move this up so we can see. Then we've got dy dx, open up bracket, sorry, this is a new stylus that I'm using, so I'm just getting used to the way it's writing. So it doesn't always look so pretty, although my handwriting is not that pretty anyway. So what you're gonna do, right? Minus y cos xy over 2 square root xy over 2 root x. Okay, so you want to have the dy dx by itself, so you want to divide through by this bracket over here. Now before you do that, you'll notice in the bracket you've got two different terms. It's always easier to make it simpler for yourself. So let's simplify the left-hand side, making those two terms one term, and I'm going to do the same with the right-hand side because it's just easier. Okay. You always want to make your work as easy as possible. Don't make it more complicated. It's not necessary. xy, right? So there, it's the same denominator, so the numerator stays the same. Right? This one divides into that one. The only thing you have left is the square root of x. So minus the square root of x, and I'm going to do the same on the right hand side. Right? That is the same, so then we can keep our numerator. If you divide this into that one, then all you have left is square root of y. Okay, so you see now it's actually easier to simplify because you're going to divide through by this expression here, which means I'm going to have, sorry, that must be dy. So let's see, minus y cos square root xy minus square root of y over 2 xy dividing by this, right? So effectively multiplying by the inverse of it. So it's going to be 2 root xy over x cos square root xy minus square root x. Okay. And then these two are going to simplify out. Right, they cancel with one another. So then all we are left with is minus y cos square root xy minus square root of y over x cos square root xy minus square root x. Okay, so that is the derivative. But now let's go back to the question. Okay, so let's see here. The question says you need to prove that dy dx looks like this. Okay, so really what we need to do is we need to take our answer. All right, let's just take our answer like this. And show that you can rewrite this into the form on the paper, right? So you need to rewrite your answer into this over here, okay? So what you'll notice, the question is really now, how do you do this, right? How do you know which rules you're supposed to use, and how do you know in what order you're supposed to use, you know, that kind of thing. Well, it doesn't really matter what order you do things in, okay? As long as every step that you take takes you closer to your answer, not further away. Okay, so you look at this answer that they gave you and you look for clues. So you can see here that your numerator, for example, you've got a 1 here, and then your cosine term is in your second part of the bracket. So if I look at what I've got, so that means that I need a 1, right? And this cosine has to be in the second part. So if I do it step by step, let's do this step by step. So I'm going to take that, put all the cosines on the other side, right? Because that's what it looks like in the question they give you, right? Even this cosine is in the second part of the term. So let's change it around. So then that was plus x cos square root xy. Okay. And that must be minus over there, right? So there the cosines are in the place where it's supposed to be, right? Then if you look closer, again, you will see that in your brackets you have a 1 in the first part of the bracket and a 1 in the denominator as well, which means here you can't have minus square root of y and you can't have minus square root of x, right? So how do you get rid of this minus square root? You factorize it, okay? So let's do that. So I'm going to take out minus square root of y, which means the first term becomes 1. I've taken out a minus, which means that becomes plus. So square root of y multiplied by what is going to give you y, right? And the answer is just square root of y, yeah? Because that square root means a half, so you've got effectively y to the power half multiplied by y to the power half. The powers would add and it'll give you y to the power 1. And that's where the exponent rules come in. And what you've got left is cos xy, right? And put everything over. What do I need here? I need a 1, which means I need to factorize this out. So that becomes minus square root of x times 1 plus, this is the same as the numerator, xy, and that is going to be equal to, those cancel, the minus and the minus. So you've got square root y over square root x times 1 plus square root y cos square root xy over 1 plus square root x times cos square root xy. Right? And that is our derivative, which is exactly what they've asked you to do in your question. Right? So that is the answer, and you say, therefore, it is proven. right? Well, I hope that was helpful to you. Please, if you've got any comments, please leave them below. And then I'll see you next time for another worked example. Bye.